Hello, everyone. Previously, we learned the basic principles of defect detection. To deepen your understanding, we will now walk through the steps of print inspection with a hands-on experiment. The process mainly includes the following steps. First, it's the NV Viewer software operation. Open the NV Viewer software and connect the camera to obtain an image. Set the IP address of the black and white 2D camera. Connect the camera network cable and 12 volts DC power cable to the Ethernet port and power supply respectively. Adjust parameters in the Common Parameters section to obtain a clear image. Once the clear image is captured, close the NV Viewer software and open the KiMage software. Set the light source channel parameters. Connect the parallel backlight and the tricolor top light channels in sequence. Set the light source channel parameters as shown. Set the PLC parameters as shown. After setting parameters, the first step is calibration. Open KiMage, create a new project named Print Inspection. Create a new tool group named XY Calibration to eliminate discrepancies between lens measurements and actual values. In general, use XY calibration when there's no sorting involved. Add a PLC control tool named Homing. Check the homing option, then click Execute to home the system. Each new project requires homing. Add tools in order. Light source control, camera, timer and second light source control. Double-click to open the parameter interface of the light source control tool. Set the brightness of the backlight in a light source tool to improve image clarity. Place the calibration plate on the motion platform. Move the platform so it's vertically under the camera, ensuring the calibration plate is fully visible. Double-click to open the parameter interface of the camera tool. Adjust exposure and other settings in the camera parameter interface. Double-click to open the timer tool. Set a delay of 300 milliseconds. Click the Run button of the second light source control tool. This light source tool is designed to adjust the brightness value of the light source to 0 after taking the photo, in order to reduce energy consumption. Add XY calibration tool. Add the Circle Finder tool and place it before the XY calibration tool. Click Register Image and select a complete large circle with the ROI box. Set search direction to from outside to center and polarity to white to black. Click Execute. Double-click to open the parameter window for XY calibration. Select input type as distance input. Then, in the X and Y pixel distance fields, input the radius pixel values of the circles found on the calibration plate using the Circle Finder tool. In the actual distance fields, enter the corresponding real-world radius values marked on the calibration plate. These values must correspond precisely to the circle selected in the Circle Finder tool. Finally, click the Execute button to complete the XY calibration. In the parameter interface of the XY calibration tool, you can see that the output value of pixel equivalent is very small, which indicates that the XY calibration is successful. At this point, the calibration process is complete. It is important to note that the calibration tool group does not need to be executed continuously. Execution is only required once during the project setup stage. After completing XY calibration, remove the calibration plate and replace it with a tray for placing mechanical parts. Next, we move on to the inspection process of printed boards. There are 6 printed boards in total. We'll start by preparing and debugging the procedure for the first printed board. The steps for the remaining boards can be done by copying and pasting the first board's process, with some minor adjustments. Let's continue with the hands-on operation. Create a new tool group named Print1. Double-click to open the Print 1 tool group. Add another PLC control tool and rename it to Capture Position. Add tools in order: light source control, camera, timer, and second light source control. Double-click to open the timer tool. Set a delay of 300 milliseconds. Double-click to open the parameter interface of the light source control tool. Set the brightness of the backlight in the light source tool to improve image clarity. While clicking the Run button of the camera tool, move the motion platform to find a suitable imaging position so that the camera can capture the full area of the first printed board. Double-click to open the camera tool's parameter interface. Under the Image Settings tab, adjust the camera exposure to ensure image quality. Note: you must adjust both camera exposure and light source brightness until the printed text becomes clearly visible. Once the exposure is correctly set, do not change it again. Changing exposure afterward will directly affect the defect detection results. After capturing the image, determine the current photo position coordinates. Double-click the PLC control tool. Check Control Settings. Get Position. Click Execute. Then check Motion Settings. Open the Axis Position interface to view the X and Y coordinates of the capture position. Add the X-axis and Y-axis values to the Motion Settings field. Later, clicking Run for this PLC tool will return the system to this exact position. Click the Run button for each tool in sequence. Add QR code detection tool. Double-click to open the tool's parameter interface. In the Output Parameters section, click and drag the search result to the right-hand display area. Add Shape Matching tool. Double-click to open the parameter interface. In the Basic Parameters tab, click the drop-down next to Tool Binding and select Input Image. In the Variable Reference window that pops up, check the Camera Output Image under the Print 1 tool group. Return to the parameter interface and click Register Image. A blue template area will appear on the right-hand side display. Upon closer inspection, you'll find that all 6 prints contain the letters G and Z. So we can use these letters as key features for positioning. Click and drag the mouse to enclose these letters in the blue area. This sets the detection feature region. Then, click Set Center. Create Template. Execute. You can slightly lower the template score threshold to reduce errors and make detection more robust. Click Execute again to confirm. After the shape matching is completed, the detection can be carried out. Add Defect Detection tool. Double-click to open the parameter interface. Click Register Image. 2 colored boxes will appear in the display area. Blue box is the area to be inspected for defects. Red box is the area to be masked. Drag the red box to the region that should be excluded from detection. Click Execute. This step is crucial because some of the QR codes on the 6 printed boards are different and may be mistakenly identified as defects. So, masking is necessary. Click Register Image again. Drag the blue box to enclose the pattern area of the printed product. Click Execute. The defect detection tool can determine whether there are defects in the image and count the number of defects, their area, and other parameters. To display the inspection results visually, we need to configure OpenNG Judgment. Click Parameters, locate number of found defects under Output Parameters, then enter the Settings interface. In the comparison type, choose Equal. This allows the defect detection tool to judge whether the number of defects is 0. Click Execute. Then, under Input Parameters, click the Result button and drag it to the right display area. Set font color, font size, and display text. Click Run. If the 7-step defect detection tool shows red, double-click the tool and adjust parameters based on actual needs. Since the later board inspections will adjust parameters based on Plate 1, make sure Plate 1 uses a defect-free reference sample. Adjust the threshold value until the result displays OK. Click Run again, and verify display results are normal. After play 1 is complete, you need to create 6 tool groups in total by copying the first tool group 5 more times. The steps for the next 5 tool groups are all the same. Only the capture positions need to be adjusted for each. Rename each tool group accordingly for easy identification. Set Print 1 as the Start module. Double-click to open Print 2 tool group. Click Run for the light source and camera tools. Move the platform to corresponding board location. Modify the position data of the capture position. Double-click the PLC control tool, check Control Settings, Get Position, click Execute, then check Motion Settings. Open the Axis Position interface and input the X and Y coordinates to the Motion Settings fields. Click Run for each tool in sequence. Each tool group requires double-click the QR code detection tool. Click and drag the search result to the display area. After clicking the Run button of the defect detection tool, if no result appears in the display area on the right, you need to double-click to open the defect detection tool's parameter interface. Then click and drag the result button under Input Parameters to the display area on the right, and set the font color, font size, and displayed text accordingly. Run the full workflow again. It can be observed that although the defect detection tool has identified the problematic areas but it's not obvious, adjust the threshold value. The goal is to make defective characters highlighted in red, while good ones should remain unchanged. After each adjustment, click Execute until the display is accurate. The same applies for the other boards. No need to repeat the explanation here. After setting up all 6 tool groups, click the Run button in the top left corner of the software to execute the entire workflow. Once results refresh, you'll see that only one board shows OK, while the others are marked as NG. Everyone, this wraps up the hands-on session for print inspection. You can watch the video while operating, which will help enhance the understanding of this content. As the saying goes, the palest ink is better than the best memory. This lesson is now concluded. Goodbye, everyone.